Okay, welcome back to Unit 8 of our Blueprint Reading textbook in our MECH 1000 class. Hopefully this will be the last video for Unit 8, and we're going to talk about a few different types of sections. So earlier in this unit we talked about section views, and we talked about full sections and half sections, but we've got a few more types of sections to discuss. So the first of these additional types of sections are revolved sections. So these are sections in which the section view is actually right on top of where that section is found. So instead of having, for instance, in this drawing, a cutting plane line here, indicating like a section AA, and then showing that section view off to the side somewhere. Instead, that section view is just shown right here, right in its place. It's as if we just cut out a section of the part and revolved it 90 degrees so that we're seeing it from a perpendicular angle. So this and this are both examples of revolved sections. The next type of section is a broken out section. So these sections are used when we may not need to cut through the entire object. There's just some particular part of it that we would like to view in more detail. So here we have a few examples of this, where we have this short break line, this thick jagged line, and it's almost as if we've just kind of broken a chunk off of this part, where above the break line we see section lines. We're seeing the internal features of this part. And below the break line, we see it just as we would from the outside. So these internal features are shown with hidden lines because we can't see them, but above the broken line we can, because we've broken away the material that was hiding it. And again here, another example with the short break line, breaking out a chunk of this part so that we can see the internal features below the line, but not above the line. Now, this brings us to sort of an odd issue, and that is when we are dealing with a part that has a rib, the ribs are not shown with section lines in the section view. So, for instance, here we have what we call the hub and a flange, and the ribs are these right here. They're sort of triangular in shape, as you can see here from this section view. It's like a triangle shape. And it has a certain thickness. It's usually made of like if it's not cast into place, then it's welded into place. It's cut out of a plate, a steel plate. And it gives added strength or stability to the central hub. Now, when we cut through this part with a cutting plane line, this rib is solid material. So you might think that we should see section lines going through there because we are cutting through solid material. But that would sort of give a false impression to the viewer of the thickness of this part, and so we don't actually use section lines for ribs. So it sort of breaks the rule of using section lines wherever we cut through solid material. Even though that rib is made out of solid material, we don't show it. And this is just another example. In fact, in this example, we have a triangular shaped rib on this side. So we see the rib here with the section lines omitted. And out here at this end, we have this sort of a semicircular tab with a hole in it. Again, that's solid material. And so if we were to follow the rules to the letter, we would be showing section lines there. But that's going to give sort of a false idea of the thickness of this object. And so we omit those section lines. We show the rib here, we just don't fill it in with section lines. lines. Okay, so let's look at another example exercise. What type of section is the front view? So here we have our first half section. We can see section lines on the right half. On the left half of this front view, we see hidden lines. So this is only a half section. What is the name of the partial section shown on the front view? So that would be this view right here. This is the type of section we just introduced, a revolved section. What is the radius on the face of the ribs? Now this one is always a little bit confusing because I think some people interpret this question as meaning this radius, the radius of this curve here, because this is a rib. It's not triangular in shape, it's curved, but that's not what is meant by the face of the rib. Instead, what this question is asking about is the rib itself has a thickness of 0.30. And I guess the assumption that we're kind of making is that it's rounded off, and that rounded end, this radius right here, is the radius is equal to half the thickness of that rib. So 0.30 divided by 2 gives us a radius of 0.15. Let's look at a few more examples. The type of section shown here, we've got this short break line where we're only seeing section lines above that. So this is a broken out section. Is the counterbore larger than the countersink? So we have to look at the symbols. Here's the counterbore symbol. It's 0.625 in diameter, and the countersink is 0.60. So the countersink is smaller. So when it asks, is the counterbore larger? The answer is yes. So these section lines that we've been seeing, for the most part, have been parallel, diagonal, regularly spaced lines. And that is the type of section line used for most materials, or it's just used as a default placeholder. But that's not the only type of section line that can be used. So here we see the section lines that we've been seeing, used for cast iron or general use for all materials. Then we have some patterns like this for cork, felt fabric, leather. We don't really use that a whole lot in this class. Here we have marble, slate, glass, porcelain. Again, not very commonly used in mechanical prints. That would be more common in architectural drawings. Steel, though, we will be seeing some drawings with steel. So the difference here is that the two lines are spaced closer together, and then there's a bigger gap, and then there's another pair of lines with a bigger gap. And then the rest of these are more for architectural or civil type drawings. We have sound insulation, earth, rock. Here's a pattern we might see in mechanical drawings, alternating every other line being dashed, continuous, dashed, continuous. That's used for bronze, brass, or copper. And then the cross-hatching with the diagonal lines going in both directions, intersecting at right angles, is used for zinc, lead, and other alloys. And then here's one for titanium. Two solid lines, dashed line, two solid lines, dashed line. And then this is another one for metals that we might see in a mechanical drawing. For magnesium or aluminum, the diagonal lines with dashed lines going in the perpendicular direction. Rubber or plastic can be shown with 4 lines, diagonal lines spaced close together, and a gap, and then 4 more lines. And again, I've been kind of omitting the architectural type patterns because we don't do really a whole lot of architectural prints. And the next thing about section views is some features that may not normally show up in the cutting plane line. We sometimes use our imagination to rotate them into position so that they can be shown because That's they contain important information that needs to be seen, and so we would like to see that information in just one section drawing. So for instance, here we have another flanged hub with 3 ribs and 3 flange holes. Now if we just simply cut a section line straight through it in a vertical direction, really we would only be cutting through 1 hole and 1 rib, which would lead to kind of an asymmetrical looking section view. And so what we do is we take this hole that isn't really on this cutting plane line and we rotate it up here as if it were. And then we do the same thing with this rib. We rotate it over as if it were there so that we end up with this nice symmetrical looking section view. And although that rib and that hole don't really lie on the cutting plane line, it just makes for a neater looking section view. So again, this usually happens when you have an odd number of features that are rotated about a central position. So if we cut the cutting plane line straight through from top to bottom, we would cut through the rib here, but not here. And that would lead to a weird looking section view. So we rotate one of these spokes over so that we see the spoke here. Spoke B is revolved into place. And then I believe the last type of section to be introduced in this section or this unit is the removed section. And this is probably actually one of the more common types of sections where you have your cutting plane line and you label it typically with letters like A and A so that somewhere else on the drawing off to the side you can draw that section view and label it as section AA so that we can see the corresponding location of this view. Sometimes, like especially in architectural drawings, the section views are shown on a different sheet altogether. So it's somewhere else in the drawing set, not even on the same page. So you have to look at the way the section is labeled and then find that corresponding section, perhaps even on a different page. Here are a couple removed sections. Now these removed sections are just simply put off to the side, but they could be moved elsewhere on the drawing as well, so long as they are labeled properly. Nope, I forgot there's at least one more type of section view here, the offset section. So sometimes there are multiple features that you want to highlight in the section view, and they're not aligned with each other. That's not a problem. You just take your cutting plane line, come over through one hole, and then just jog it up and pass through the other hole. That way your section view shows both holes. And so you don't have to do 2 separate sections. You can just do one section with an offset section line. Here's an example of that, passing through this hole, and then it jogs up through the other one, back down through the third hole. So that in the section view, we can see all 3 holes. And so this reduces the number of section views that need to be created in order to show all 3 of these holes. We wouldn't necessarily want to create 3 separate section views when we could just do 1. So that brings us to the end of Unit 8. As always, if you have any questions, you can leave them on our Blackboard discussion board or be sure to ask them in class.